An important concept in science when we deal with forces is the concept of work. Now, we're all familiar with work, and work has many different terms in our common everyday life. Work, for example, can involve being at a job site. Work can involve thinking for us academic people. Work can involve writing a letter. Work can involve digging a hole in the ground. Now, work involves doing something. In the case of a scientific definition of work, we have a very specific definition. So, for example, if I take this 2 kilogram mass and I hold it simply at this height for as long as I want, I'm doing no work. I'm expending energy. My muscles are using energy to lift up the mass, but no work is being done on the object. It's really the same as if the desk is supporting the object. The gravitational force is actually pulling down on the object. The desktop is countering that with an upward force, and so the object remains at rest. Our scientific definition of work involves then two things. It involves, first of all, the idea of a force that has to be applied to the object, and secondly, the force actually has to cause a movement of the object. And so the formula that we use for work is work equals force times a distance. If I take this mass now, this is a 2 kilogram mass, and I lift that with my spring scale, we can then measure the force on that. A 2 kilogram mass will have a force of about 20 newtons. If I lift this through a distance of 1 meter, the work that I do is then calculated as follows. 20 newtons is my force times 1 meter, which is then equal to 20 Newton meters. The Newton meters is given another common unit that we call the joule. So 1 Newton meter is equal to 1 joule. A joule is a unit that we use for work. It's also a unit of energy in the metric system. So then to lift up a 2 kilogram mass, as what I have here, through a distance of 1 meter requires 20 joules of energy, and I then do 20 joules of work on the object. So the amount of work done is 20 joules. I also then expend energy to lift it up, and so therefore I use also 20 joules of energy to lift it up. To calculate the amount of work I do in sliding an object such as a book across the countertop, I need to measure the force that I use to slide it, and I can do that with my spring scale, and I need to measure the distance that I slide the book along the table. So let's set it here, and then I pull the book. You'll notice that the spring scale does move a little bit as I pull it, but it averages about 4.5 newtons or so. So the work that I do in pulling this book is then the force times the distance, which is then 4.5 newtons times 1.0 meter, and that is then 4.5 Newton meters, which is then 4.5 joules. So the work that we do there is 4.5 joules. And that work is necessary to overcome friction. If I lift the object up and I simply move it across, I'm not doing any work because there's no frictional force that I'm overcoming. I'm using my muscle power to lift the object, but I'm not lifting it any higher. If I keep it at the same height, the frictional force here is 0, and so the work that I'm doing on the book in terms of moving it from one side to the other is really 0, because the force in this case is 0. The force along the horizontal distance is 0. The distance can still be 1 meter, but my force is 0. If I lift the book up, then I'm doing work. I then have to use a spring scale to measure the force, and the force in this case is about 19 newtons. And so if I lift it up, we then take the force that I'm using, 19 newtons, and multiply it by the distance that I'm lifting it up, which then gives me the amount of work.